Hi, my name's Erica.
And I'm Michelle, and today we're going to be talking about chapter 17, which is on blood.
So in this video, we're going to explain the blood, its components and functions. So for a basic overview, males have about 5 to 6 liters of blood, whereas females only have 4 to 5. Blood components consist of connective tissue due to the fact of the widely scattered cells in a matrix. Cells are formed elements. 3 kinds of formed elements in the blood are RBC, aka erythrocytes, WBC, called leukocytes, and platelets. So RBC makes up about 45% of blood volume and carry oxygen. WBC make up less than 1% of blood volume and it fights infection. Platelets make up 1% of blood volume and clot blood. Blood also contains plasma, which is a fluid matrix making up 55% of blood volume.
Moving on to the blood characteristics, the normal pH level is 7.35 to 7.45, a basic solution. Bringing your pH level back to normal is called homeostasis. Your normal blood temperature should be 100.4 degrees Fahrenheit. Moving on, there are 3 functions of the blood. This includes distribution, regulation, and protection. Under distribution, it distributes oxygen and nutrients throughout the body. It collects and removes waste from the nutrients. And lastly, it transports hormones. Under regulation, it regulates the temperature. Blood also regulates pH because it contains chemical buffers, and it also maintains fluid volume, and it has a lot of dissolved solutes. Under protection, it prevents blood loss and uses platelets and proteins to do so. Proteins include antibodies that inform the immune system about bad bacteria, in turn preventing infection.
Getting more specific, we will now discuss blood plasma. 90% of its composition is H2O, which is also water, and the remaining 10% consists of solutes. Proteins. Most proteins are soluble in water. Albumin is a carrier that moves things around that are not soluble in water, such as lipids. It also is a buffer, and it also contributes to osmotic pressure. Overall, it's the most prevalent protein in plasma. Next up is globulins. Gamma is an antibody. Alpha and beta are both transport proteins that are made by the liver. Next is clotting agents, also known as fibrinogen and prothrombin, which is also produced by the liver. Lastly, there are also hormones and enzymes. Moving next to nutrients. Different nutrients are like glucose, amino acids, fatty acids, and glycerol. There are also electrolytes in the plasma, such as salt, that are charged particles. There are also respiratory gases, such as some oxygen is dissolved in plasma, but there is more carbon dioxide than oxygen. There are also non-protein nitrogenous substances, which involves galactic acid and urea.
The first form element we are going to talk about is erythrocytes, also known as red blood cells. Their structure allows diffusion in and out of the cells perfectly because the volume throughout the cell is the same. Spectrin is the protein that gives erythrocytes their shape. Their function includes the hemoglobin transporting up to 4 oxygen molecules. The structure of hemoglobin is made up of 2 alpha and 2 beta chains. Each chain holds a heme group, which holds 1 iron, and each iron holds 1 oxygen. Oxygen is loaded in the alveoli of lungs, causing the hemoglobin to change shape, making it into an oxyhemoglobin. Oxygen detaches in the tissue, then it forms into a deoxyhemoglobin, which is carried to the lungs. Carbon dioxide binds with amino acids of globin to form carbaminohemoglobin.
The general blood cell formation is called hematopoiesis or hemopoiesis. In this formation, it starts off as a hemocytoblast and forms into all the formed elements. Though the production of red blood cells is erythropoiesis. This occurs in the red bone marrow, which is also spongy bone. First, the blood cell starts as a hemocytoblast next to the proerythroblast, to an early erythroblast, a late erythroblast, a normal blast, a reticulocyte, and lastly to an erythrocyte. Erythropoiesis is regulated by hormonal control, positive feedback to be specific. For example, the oxygen in the kidneys are running low, so proteins are sent for RBC production. RBC production is stimulated by erythropoietin, which goes to the red bone marrow. For erythropoiesis to occur, vitamin B12, folic acid, and iron is required.
The life cycle of a typical red blood cell is a maximum of 120 days. After the cell dies, the spleen traps the dead red blood cell, creating a red blood cell graveyard. The dead red blood cells are broken down by macrophages, and elements from the cells are stored and recycled. There are also clinical problems associated with red blood cells. They are anemia and polycythemia. Anemia is reduced oxygen carrying capacity in blood, also a sign that something is wrong. This is caused by decreased numbers of red blood cells, decreased numbers of hemoglobin levels, and abnormal hemoglobin from genetics. Polycythemia is where there are too many red blood cells, which is the opposite of anemia. The next formed element we are going to talk about is leukocytes, which are white blood cells. It functions as an immune defense. When white blood cells are responding to an infection, it is called leukocytosis. There are different categories of white blood cells: granulocytes, which contain granules, and agranulocytes, which don't have any granules. There are three different granulocyte types. There are three different types of granulocytes. First is neutrophils, which perform phagocytosis at the site of an acute infection. Next is eosinophils, which fight parasitic worms and produce antihistamine. And lastly, basophils, which release histamine and cause inflammation. Next, agranulocytes have only two types. The first one is lymphocytes, which produces antibodies and destroys cancer and virus cells. And the last one is monocytes, which does phagocytosis at a chronic infection site.
Leukapheresis is the process of making white blood cells. The colony-stimulating factors guides the production of specific leukocytes. Just like red blood cells, white blood cells have a formation pathway too. They all start from a hemocytoblast, which is stimulated by a stem cell growth factor. Lymphocytes branch off first. They start off as lymphoblasts, then lymphocytes. Others derive from a myeloid stem cell. Monoblasts become monocytes, while myeloblasts can form into neutrophilic, eosinophilic, and basophilic. All three start off as band cells before becoming matured. Say leukemia, one clinical problem for white blood cells. It's an uncontrolled growth of white blood cells, which is a cancer. The last of formed elements are platelets. They also come from hemocytoblasts but are not cells, just pieces of cells, and their function is to form clots. Next, we will be discussing about the process of homeostasis. This is known for keeping the blood within the body. Most importantly, the body uses platelet plug formation. At the site of the damaged blood vessel endothelium, platelets will swell while getting spiky and sticky. Platelets stick to the exposed collagen, then degranulate. Serotonin, which increases vascular spasm, and ADP, which the ADP attracts more platelets and stimulates them to degranulate. Prostaglandins control the size of the clot, and thromboxane A2 is derived from prostaglandins, which aggregates platelets and stimulates vasoconstriction.
Next is blood clotting, also known as coagulation. There are three phases to coagulation. The first phase is either intrinsic or extrinsic pathways. Intrinsic takes a longer process than extrinsic because it has many intermediate steps, though they both lead to the same results in producing prothrombin activator. The extrinsic pathway is shorter and less complex, but it needs extra tissues to go faster. The second phase is to convert prothrombin to thrombin through the use of the prothrombin activator. The last phase is to form fibrin mesh. The thrombin converts fibrinogen to fibrin with calcium stabilizing fibrin. This also activates platelets to form stable structures for a clot. Within 30 to 60 minutes, actomyosin protein complex contracts to form a scab. While the scab is forming, the vessel is healing through platelet-derived growth factor, which stimulates smooth muscle cells and fibroblasts to divide and rebuild the vessel walls. Of course, the scab is not permanent, so a process known as fibrinolysis removes all the clots when it's not needed anymore. Plasmin that is produced by plasminogen tears it down.
Last but not least, we are going to talk about blood transfusions. There are 4 blood types: A, B, AB, which is the rarest, and O, which is the most common. So here we drew the blood transfusion or the blood type diagram. I also need to point out that Rh is rhesus, and it determines if the blood type is positive or negative. So when getting a blood transfusion, you must receive a compatible blood type, or else the red blood cell clots and antibodies will react with each other. So I'm going to talk about and basically read you the chart of the relationships between blood types and antibodies. So say if your blood type is A, the antigens on the red blood cell is A. People with the blood type A can donate to types of A and AB. and the antibodies is anti-B. And if you're a blood type A, you can also receive blood from A and O. With blood type B, the antigens are B. You can donate to B and AB. The antibodies in the serum is anti-A, and you can receive blood from B and O. With type AB blood, the antigens on the red blood cell is A and B. You can donate to only AB, and the antibodies in the serum is none. There's no antibodies. You can also receive blood from A, B, and O. And if you're blood type O, there are no antigens. You can donate blood to A, B, and O, which is all the blood types. It's a universal donor. And the antibodies in the serum is anti-A and anti-B. And you can only receive blood from type O. That's it.
Woo, and this is a wrap. We done. We out. We out of here.
Thanks for watching.
Bye, guys. Such a midget. Such a midget.
Michelle, please.
You got it.
I can't reach that. Can't reach that.
I got it.
Showing people problems.
Male have 5 to 6 liters.
Liters.
Liters. Restart.
Hi, my name's... You done?
Yes. I'm so sorry. I can't do this.
Widely scattered cells in a metric. Sales. Whenever you're ready.
Oh, I thought you said you go first.
Oh, okay. Hi, my name's Erica.
Wait.
5 to 6 liters of blood, whereas females only have...
I was trying to follow your lead, but like it wasn't happening. I was gonna go 5 to 6, but I was too slow. Why are you laughing now, bro?
Whereas W...
In it.
You could just go underneath it.
Oh, you're right. Da, 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 da.
Okay. Platelets make up 1% of blood volume.
Okay. So 7.45. A basic solution.
Whenever you're ready.
Okay. Which maintains. Why would I say that? I don't know. Why would I say that? Why'd you look at me like that?
Or
I just restart. We blah 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 blah. Okay.
secondly is global. It's also known as fibrinogen.
It's like a bun.
Bun. That was the first word.
I know, like I can't even say anything. Him. I always want to say hem. I don't know why, but I meant him. Stop. Evoli.
Ebola?
Evoli. What is Evoli? I don't know. I hate myself. I literally hate myself.
That's though, not throw. Throw.
I can't read for life. What'd you do though?
I added this because I just produced a system because I was reading off your notes that you handed me, like that paper, and it didn't say cause inflammation, so I was writing inflammation, then I wrote inflation.
Which release histamine and cause inflation. Inflammation. What I said inflation.
Cells. The colonnades. I have a British accent now. The colonnade. I can't pronounce colony. I am suffering.
The colony.
I keep coming in with a British accent. I don't know
it's
why.
It's okay. Just say it.
Should I just talk in a British accent? Others derive from but are not just cells. But they are not cells. They are just not cells. What do I think? No.
Like make it to where like the chair's not noticeable, you know, right there. You still look short. I'm dead.
No, it's better if I just.
Wait, just higher the chair.
That's why she's the Asian one here.
That's what we thinking. Yeah, you ghetto Asian. I know, but like. Why are you doing that? You can see that.
Oh, it doesn't matter.
It's. I can't speak. I'm so mad.